I just noticed that. So my name's Tony. So for this workshop, this will be an introduction to GraphQL with Node.js and MongoDB. And so first I want to start off with what is GraphQL. And so at a high level, so GraphQL is so it stands for Graph Query Language. And so it's a quote unquote query language that describes your API and helps facilitate communications between a client and a server, and it's also a server side runtime for executing queries. And so that's kind of a lot. So we can kind of unpack that a little bit. So I think one like big misconception I had with GraphQL when I first heard about it was that I thought it was supposed to be like SQL, um, in that it was supposed to be like a query language for a database, but that's actually not the case for GraphQL. So GraphQL is really a specification for how a client and a server and a client-server architecture should communicate with each other. And I guess it's like a query language in the sense that it defines what the client can query from the server. So inherently, it doesn't have anything to do with a database, but it's very common that you'd probably want so if you're making like an API for a data to, I guess, like interface a database, you would most likely want your GraphQL schema to be very similar to your database schema. Um, and so one of the big benefits of GraphQL is that it basically gives the data in your API a static typing, and so you can explicitly define data what data requests should send to the server, and then explicitly define what clients should expect back from the server. Um, and it Another really big benefit is that it lets clients define exactly what data they want from the response out of all the possible data that a response could contain. So, for example, so like this is really good for like optimizing bandwidth or how you're using your bandwidth. So say I have a query that's going to a server, and it's going to get all the information about a user. So this could be like a first name, a last name, an email, a password, any friends that they have. Say this is a social media application, and then like any posts that they've made. And so I might be querying for this data, but maybe all I care about is the posts that that user made. Maybe I don't necessarily care about all that user's friends. So even though it's I could get all the friends from that query for that user, I don't need to receive it. And that's a really big benefit of GraphQL that technologies like REST don't give you. Um, GraphQL also has a really rich toolchain and language support. And so let's take a look at this a little bit. So this is on graphql.org. So this is basically GraphQL's like homepage. And so this is all the language support that, according to this website, GraphQL has. So you can use GraphQL in virtually any language that you would want. But some languages are going to be more powerful than others with GraphQL. So JavaScript is very powerful with GraphQL. Rust, I imagine, would also be very popular because Rust has a very devoted community. Something like D or Perl, probably like you can probably get the job done, but it's not going to be as easy, and there isn't going to be as big of a community to help you out. So let's switch back to the presentation. And another fact about GraphQL is that it was originally made by Facebook in 2012, but it's currently governed by the GraphQL Foundation, which is just their overarching body. So now let's kind of let's take more of a deep dive into GraphQL. Except it's not really a deep dive. We're really only scratching the surface with this presentation. But so this is kind of like what GraphQL looks like. So on the leftmost side here, you can see, whoops. On the leftmost side here, you can see an example of how we would define a GraphQL schema. So at the top here, we're defining a type called query, and inside this type, there's a field that returns a user. And then underneath here, we have a type called user, which has a field called ID, which is of type ID, and then a field called name, which is of type string. And so something you might notice about this GraphQL schema is that it looks very similar to, I guess, like how you define variables and types looks very similar to more modern languages such as TypeScript, Swift, and Rust. It's not really the C standard where you would do like int a equals 0. So that's one interesting thing. And so in the middle right here is an example of how we would actually, I guess, create a GraphQL query. So there's going to be a root. There's like a root object, which are these opening and closing curly braces on the outermost side here. And then we have on the inside here, we're basically telling GraphQL what query we're trying to make. And then we open another object here, and then right here we can define all the fields that we want to get back. So as I was kind of showing before, we have under this type query. So I'll explain what a query is a special type in GraphQL, which I'll explain more later. But basically, in this query type, me is actually a me is called a query, and it returns a user. And this is different from the type user, which is defining fields and types. So if I have something in this type query, it's really an operation and a return value. And if I have something other than outside a query, like a user, it's more of a field and type. So in this little mini schema, we're defining that the query is going to return a user. And then if we go to user right here, so I could pick any of these things to get back from GraphQL. So I could say ID and name, I could do just name, or I could do ID. And then on the right side here, we have an example of the response that we'd get back. And so this is in standard JSON format. Whoops. So that's kind of I guess, GraphQL at a very high level. So the next thing I want to talk about before I move on to other things are scalar types in GraphQL. And so these are basically just like data types, basic data types that you would learn about in any sort of programming language. So, and GraphQL has the basics. So it has an int, it has a float, a string, a boolean, and an ID. The ID is actually kind of the outlier here. So it's supposed to represent a unique identifier, but it's serialized the same way as a string. And so if I had a certain type in GraphQL and I needed that to point to an ID of another type, then I could store that as a string because it's serialized because IDs are serialized as strings. What's also cool is that you can create custom scalars. So if you wanted to make a date scalar or an email scalar, you could do that, but you just have to define how they're serialized, deserialized, and validated. And so to talk a little bit more about more GraphQL type stuff, so what's also cool about GraphQL is that you can define what fields should be non-nullable. And so that means that that field should never be null. And if it ever is null, then GraphQL will throw an error. And the way we define a non-nullable field is by using the exclamation point. And so I have an example right here. So you could say password is a string and it's non-nullable. So every user should have a password, for example. And if the user somehow doesn't have a password, then there's probably a problem. And what's also interesting is if anybody's familiar with optionals in other languages like Swift, the exclamation point kind of reminds me of that a little bit. So like in Swift, you would use an exclamation point to like unwrap a variable and say that it'll never be null. But say it's kind of similar to that, and it reminds me of that a little bit. And then another cool thing in GraphQL is that you can make lists as well, and you just annotate that with a opening and closing bracket. And an example would be right here. So for whatever reason I want a list of emails, then I would just do string encased in an opening and closing bracket, which would mean a list of strings. And I could use any scalar type there. Any scalar, custom scalar, or custom type, and I'll get into custom types in a little bit. And so what's also very cool is that I can combine the concept of non-nullability in lists. So, and here's a few examples. So I could have, basically what this first example is saying is, I would have a list of strings. The strings themselves could be null, but the list itself will never be null. And then the second example here is saying that I could have a list, but all of the values inside of the list should never be null. So there'll always be a string, but the list itself could be null. We don't know if it actually exists or not. And then the final example here is saying a list of strings and the items in the list are never going to be null. They'll always be strings, and the list itself will never be null either. So that could be, so even if it's just like an empty list, that's fine, but never null. So next I'm going to talk about how to define types and talk a little bit more about fields. So it's very simple to define a custom type in GraphQL. So all you have to do is you just type and then whatever you want. So it could be type user, type post, or type comment. And whenever I say type user, I open and close curly braces, and then inside of those curly braces, I can make I can give that type any fields that I want to give it. And so for an example here, I have a user, a post, and a comment. So I'm saying here that a user will have a unique ID, and it should the ID should never be null. And I'm also saying that the user is going to have a first name and a last name that should both be strings. And say, for example, that when the user when a development team was making their create user flow, they decided to give the user a choice of whether or not they want to enter their first name and last name. So that's an example of where it could be null. Alternatively, what you could do is you could say you can make first name and last name non-nullable, and if the user didn't enter a first name and last name, you could just put in an empty string. So that's another way to go about it. I'm also saying they're having an email, which is a string that'll never be null, a password, a string that'll never be null, and then a list of posts that the user made. And so, like I mentioned earlier, when I am defining types for fields, I can use any scalar or type. So any of these other custom types that I've defined, I can put inside of a field, like I'm doing right here for the user. And basically, that can kind of give you a lot of power, because if I query for a user, then in that same query I can get all that user's posts and all of the comments for that post, and I can pick and choose every single field that I'd want. So then going on the post right here, again, another unique ID that's never null. And then right here, so I have a user ID, and I'm saying that's a string that's never null. And so the idea here is that this is gonna point up to a user, and it's supposed to represent the ID of the user that created that post. And then I have a content field to store the content of the post, likes and dislikes, which are integers, and a list of comments, similar to how a user has a list of posts, and then timestamps for when the post was created and when the post was updated. And then lastly, I have a comment here. So another unique identifier, then the post ID, which is very similar, basically the same idea as the user ID in the post. So it points to the post that this is a comment of. The content of the post, a string that's never null, likes and dislikes, integers that are never null, and then again, timestamps for created at and updated at, which are strings that are never null. And so the next thing I want to talk about in GraphQL are two special types of types, and they are called query and mutation. And so they are kind of like keywords in a sense, in that you can't really create any other types that have the same name as query or mutation. Um, and basically, the idea is that the query is going to represent anything in the anything that will read data, so which would be the R in CRUD, and then mutations are going to represent the create, update, and delete in CRUD. So their mutations are going to be dealing with anything that like modifies data or creates it. And any queries and mutations that you create can also accept arguments. And actually, another interesting thing that I didn't talk about for types and fields was that fields themselves can also accept arguments. We're not really going to talk about that during this presentation, but if say I had so okay, say like this created at field was actually well, yeah, so say I have this created at field. So I could pass an argument into that field when I'm querying the data that would say like maybe like um what like what metric of time I want to get that back in. So I could say like I want to get it back in minutes, I could get it back in seconds or hours. So that's like an example of how you could use a or passing an argument in for a field. Um, but in terms of passing in arguments to queries and mutations, this is helpful for things like if you want to find a user by a certain ID. And so I'll show some examples here. So I have an example of a type query. And so inside of this query is where I'm defining all the queries that a user could perform on my API. So I'm saying there's going to be a get all posts operation, which returns a list of posts that should never be null. And then there's also a get posts by user ID, and this is how we define arguments for queries in GraphQL, queries and mutations. You just have an opening and curly parentheses right next to the operation name, and then you give your variables names and then types for the variables. And if I wanted to have more than one parameter, I would just separate them by comma. But this is definitely a little bit different than like Java or how you would define function parameters in Java and C. So it looks a little weird at first. And then I'm saying the return value for this is also another list of posts that should never be null. And then lastly here, I have a operation called whatever. And so I will be explaining why it's called whatever later. But it is my intention was that it was an object, or sorry, an operation that would accept an email as a string and then return to the user a user who has that email. And so you might notice that the return value is a user that could be nullable. So the idea here is that if the if whoever is making this API request it gives me an email that doesn't exist anywhere in the database, then I would return null. Um, that's not maybe not necessarily the best thing to do, but that's just an example of one way. So so this is an example of how we would write up the schema. And so in terms of making the actual requests for all these operations, this is how you would do it. So so whenever you're making a request using a query in GraphQL, you want to start your request with just the word query, and then you do an opening and closing curly brace, which is this is the root object that I had mentioned earlier, and then in the first field inside of this root object should be the name of an operation that you want to perform, and then you open and close parentheses for another object, and inside that object you define all of the fields that you'd like to get back. And so if you look closely, so these are all fields that exist on a post. And what's cool is that if I, like I was trying to mention earlier, if you have nested types, then I can also get all of the fields on a comment here. So if we go back here, it's right here. So if you look at posts, so as a reminder, these are all the different fields we could get for a post. And we also had a list of comments inside of the post, which means that for all those comments, I can pick any of these other fields for those comments, and I can get back that information. And so you can see I'm getting the ID and the content of every comment, and then the ID and content of every post. And so that's really where the power. This is like kind of the power of GraphQL, right? So like I was mentioning earlier, I can define exactly what I want to get back, and like I'm not forced to get more than what I need. And then lastly, I have the other query here, which was get user by email. And so right here, I'm actually using or making an example of something in GraphQL called an alias. And so basically, or sorry, an operation name. So this concept here is called an operation name. So we had this query called whatever, but it's not really descriptive. And so when you're trying to debug things that can be or look at logs, that can be an issue because it doesn't really help you figure out what exactly was going on. So if you're ever in a situation like that, you can actually just give queries their own operation name. And so I know that whatever is supposed to be getting me a user by email, so that's what I'm naming this query, get user by email. And so you can also see in these examples how I'm passing in arguments for the operations. So if we go back, whoops. So if we go back right here, so we can see that get post by user ID takes in a user ID, which is a string, and then whatever would take in an email, which is a string. And so we can see here that I'm passing in the string 1 for the user ID, and then I didn't have enough space for the email, but imagine it's like some albany.edu email. And so I also defined in my schema that these inputs should never be null. So if I did pass in null, then I would get a GraphQL error. And so I want to execute the query, and I would get a GraphQL error. And then here's an example response. So this is an example response of the get all posts query. So it's going to be in JSON format, and then the other hallmark of GraphQL responses is that the second object here is going to be labeled data, and that is like that's like I want to say almost consistent across every GraphQL implementation. And then inside of the next object, we have the query name. So that's also something important. So if you're trying to access this data, you'd have to say like data.getAllPosts.id or something like that. And then we have our final object here, which is describing the data, the actual data the actual fields, the keys, and the key value pairs that we got back. And so this is also all in JSON. Um, I think I forgot strings. Yeah, this one should actually be a string. But yeah. And so the next thing I want to talk about are mutations. And so we'll go over this, how to define a mutation in your schema first. So similarly to how you would define a query, you would say type mutation, open and closing curly braces, and then again you would define an operation name, what the parameters are for the operation, and then what it should return. So this mutation is called create user, and it accepts a user input, and it returns a user that is non-nullable. And so something else that's cool about GraphQL is that I can define inputs for different um, queries and mutations. And so you can't actually use a custom type for an input in GraphQL, so you have to define an input. So if I go back a little bit, so on these queries for inputs, I used scalar types, and that's okay, but I can't use custom types for parameter types in GraphQL. So I can't say that the input should be a user. I have to make a user input, which is explicitly an input, and so that's the only way I can um, kind of contain the intended input inside of an object, or like kind of like a class or object in GraphQL. And so the idea here is that when a user is created, they would input maybe a first name or maybe a last name, but always an email and always a password. And then at the end of the mutation, I would return the user that was created by the server. And so here's an example of the request and response here. So, oh, sorry, this is just the request. So when you're making a mutation or a query in GraphQL, you can define variables. So if we go back here, if we look at these queries, we just set for example, get post by user ID. We just said that user ID was going to be 1. But if you say you have like 10 different arguments that you need to pass into a query, then that gets kind of messy. So that's kind of like another motivation for using this input type. And so what you can do is you can define a variable, or sorry, yeah, you can define a variable that should be passed into that mutation or that query. So right here, I'm defining a variable on the side called input, and so it's an object that holds a first name, a last name, email, and password. And so this holds up to the specification that I set in my GraphQL schema. So if you look back, so the user input has a first name, last name, email, and password, and so does my input object right here. And so when you are passing in variables to mutations and queries in GraphQL, what you do is you open up parentheses and close parentheses at the level where you're defining whether it's a query or mutation, and so you give your variable a name, and so I'm using input, and so when you're giving variables names in GraphQL, you always use the $sign first, so it's $input, so that's the name of the variable, and then the type here is a user input. And then what I have to do is I have to pass that variable into the query, into the mutation itself. So I have to pass it into create user. So create user has a parameter called input, and so I'm saying that the that I just want to put in the variable input into, or pass in the variable input as the argument for that parameter. And yeah, so it's pretty much just as easy as that. And when you're making a variable in GraphQL, you also have to use JSON. So that's the other thing that you should need to keep in mind. And then here's just another example of a response from that mutation. So just like a query, I would have in a root object and then a data key, which whose value is another object, and the key of that object would be the name of the mutation, similar to how it would be the name of the query in a query response, and then the object that I ask for, and well, I guess all the fields that I ask for the return value. And so that's like a crash course on GraphQL, and well, probably not even. There are a lot more features to GraphQL, but all those features we won't be using for this workshop. And so some other features for queries and mutations are aliases, fragments, directives, and field arguments. Field arguments I touched on a little bit, but not really. And the schema features that I didn't talk about were enums, interfaces, union types, input. Sorry, I did talk about input types. My bad. And I also didn't talk about best practices, such like thinking graphs and authorization and pagination, and also subscriptions. And so subscriptions are also a really, really big part of GraphQL. And so I only talked about queries and mutations, but subscriptions are kind of like at the same level as queries and mutations. And so subscriptions are usually implemented using WebSockets. And so I don't know a whole ton about subscriptions, but I think the idea is that you are basically like subscribing to certain data in your API, and whenever it updates, you would get the updated value back. I'm not super positive that's how it works, but yeah. And so yeah, so that's kind of GraphQL, but I would implore all of you to explore it a bit more, and I have some links at the end of this presentation for further enrichment. But the next thing I want to talk about is the project overview for what we'll be doing. So we're going to be creating an API, but before I talk about it more, I wanted to talk about what an API is. So an API is an application. Well, it stands for Application Programming Interface, but you usually refer to it as just API. And so, in a nutshell, APIs make something complex and very easy to use for most people. And so it's kind of like an abstraction layer almost, and it simplifies something that is otherwise a little difficult to understand. So, for example, you can think of a steering wheel as an API to the wheels of your car. So we have no idea how the steering wheel actually turns the wheels, but we know when we turn the steering wheel left and right, we're going to turn the wheels left and right. But internally we have no idea. Well, some people may know, but internally we have no idea of how it actually turns the wheels of the car. Another example is an electrical socket. So we have a simple way to use the electrical socket, which is just plugging whatever into it, and the expected result is that we're going to get electricity, and we're going to use the electricity in whatever electronic we're using. But internally, we have no idea how the electrical socket gets the electricity. And then another example is a car dashboard. So you can, if you think about all the knobs like on the radio of your dashboard, we have certain functions that we can perform. We can turn the volume on the radio. We can press buttons on the radio to switch stations. There's also, for example, like putting in a CD. So internally, we have no idea how that works, but all we know is that the car dashboard provides these an interface for us to use or to utilize certain functions of the radio. And so I guess my point here is that APIs are not really limited to the sense of front-end and back-end development. And so like another example here is that the C programming language is like an API to assembly, and assembly an API to machine code. And you can also say that like classes in Java typically provide an API to all the fields. So like all the you can consider all the getters and setters and mutations and accessors APIs to all the internal fields that are stored within the class. Um, Another thing you can think of is like if you ever done like Android development, um, or yeah, Android development. So there are certain functions that the Android software development kit gives you to utilize certain things of the or like sort of utilize hardware components on the phone. For example, like the camera. Um, and if you've ever done like machine learning and used like scikit-learn, there are functions for like let's say like the naive Bayes classifier, and so internally, um, some like most people probably have no idea how that works, but we know that there's a very simple and easy to use function that gives us a naive Bayes classifier based on data that we give it. Um, and so another point is that APIs can be public or internal. So like companies could have internal APIs that only um, people within the company should access, and then there are also public APIs. For example, like Twitter has an API where you can like scrape all their tweets, and same for like Facebook and things like that. And so, like I kind of mentioned before, the main benefit of an API is that it simplifies complex things and it makes things that are hard to use much easier to use for more like a broader audience. They also facilitate the separation of concerns. And so the idea of separations of concerns is that um, every module in well, the idea is that there should be, well, the idea is that systems should be modular, and each module in a system should have its own job. And so if we kind of think about APIs in the context of front end and back end development, um, our system would have clients and then a server. So basically, it removes like the server API would remove any business logic related to getting data from the database, and all the client has to be concerned with is creating function calls to the API server and getting the data back. Um, and at like a micro level, this is kind of like this. You can also talk about this like at a micro level too. So like if anybody's heard of like MVC, model view controller, that is also big on separation of concerns, where there's a model which stores all of your data, a view which presents data to the user, and then a controller which handles all the business logic. Um, and so in a way, they all kind of expose APIs to each other so that they can all utilize each other. Um, and so in the context of software development, um, oh yes, so a really big and important aspect of APIs for in software development for in like big companies or enterprise solutions is that they expose common data to the rest of the system. So I'm sure we've all been on some sort of social media app that has a website and then also like a mobile device. Um, so like for example, like Facebook for example or Instagram. But then there's also like Blackboard. So Blackboard has a website and then there's also a mobile app. So the question is, how do you get the same data? Like how do you make sure that the user sees the same data no matter what platform? And so APIs help with that. And so we can have multiple clients that are implemented differently that go to the same API and get the same data, and that's how we can make sure that no matter what platform the user is using, they can have a similar user experience. Um, and then I guess my big point here is that any client can use the same API, and that's what makes APIs really powerful. And so how do does the API actually get the data? So there are many different ways that APIs can actually get the data, but in the context of GraphQL, resolvers and data fetchers are basically what will hold the business logic and what will be concerned with actually getting data, say, from the database or from other services. GraphQL really only defines how the client and server should talk. So ultimately, it's up to you to define how these GraphQL queries and mutations actually perform and get the data, or for example, create the user. So like if we, yeah, so this is the schema. So this is the GraphQL schema for this mutation, which is create user. So literally all I'm doing is defining what the user should pass into this mutation and what the user will get back. But I'm not defining anywhere like how any of this is done. And in GraphQL, you use something called resolvers to do that heavy lifting. And in some implementations, they're called data fetchers, and there might be other names depending on other implementations too. In GraphQL Java, they're called data fetchers for whatever reason, but I think typically they're called resolvers. Yeah, so that is a little bit about that. And so then the technologies we'll be using for this project are going to be Node.js, which was advertised, GraphQL also advertised, Apollo Server, which was not advertised, but Apollo Server makes your life very, very enjoyable when you're working with GraphQL, and Mongoose, which we'll be using to interact with MongoDB, also not advertised, and then MongoDB, which was also advertised. So that is that. So that's all the presentation for now. So at the end of the interactive portion, I'll go back. But the first thing that I want to do right now, though, is set up our MongoDB. So I would like everybody who is planning on participating to go to MongoDB. So I will log in with you if you would like to follow along. So just gonna log out here. All right. So I guess I'm just gonna do my thing. And so I'll explain the steps as I'm going. But if I'm going too fast, just feel free to slow me down, or just like tell me to stop. All right. So after we log in, you might have something similar to this, and so what I want you all to do is so there might be a little drop down menu for all of you, and so these are like all the projects that I have. So we're gonna create a new project though, so this is just like a test. So click on this this drop down menu and then click on new project, and so you can give your project a name, and you can do anything. So let's do GraphQL shop real, because I did a test earlier. So after you give it a name, you can click on next, and this you can ignore. This is just adding members and giving them permissions, but we only want us to be or to have access. So once you're here, just click create project. And so this will take a minute. Actually just a few seconds. So after you've created the project, the next thing that you want to do is you want to click on build a database. And so MongoDB is very generous and they offer a free tier. So we're going to use this free tier. And so this is the shared cluster. And so the cloud provider and region we don't need to really worry about, but we're just going to scroll down here a little bit and just make sure that we have the free forever right here under cluster tier. And everything else should be fine. So basically all you need to do is just scroll down and click on create cluster. And so it's going to bring us right here. So it's asking us, how would we like to authenticate your connection? So basically what this is going to do is so we're going to make like an admin user and give them a password, and we're going to need this for when we actually connect to the database later on. So you can put in whatever you want, but I'm going to put in the admin for the username, and then I'm just going to do password 1 2 3 4 5 6 7 8 9 for my password, and then I'm just going to create the user here, and that is all good to go. And then the next thing that we want to do is so basically right now it's asking us where we'd like to connect from, but what I'd like to do is have us switch to the network access tab on the side right here. So click on that. And so we're going to add an IP address right here. And for the sake of the workshop, and to just make this easier, I'm going to click on allow access from anywhere. Alternatively, you could add your current IP address, but I'm just going to say allow access from anywhere. So after you click that, just click on confirm. And so this is the long part. Or sorry, this is not the long part. So that's going to do its thing. And so while that's doing its thing, what we want to do is we don't want to click on, we want to go back to databases over here. So we click on databases. So it says clusters being created. Oh, okay, sorry. Yeah, so so basically right now, so we're all set for now, so we to finish up, and then we'll be good to go. But so while we're waiting for this, we're gonna start coding now. So what I'd like everybody to do is to navigate to a new folder where they can put all the code relevant for the workshop. So I'm just renaming something real quick. Don't mind me. Oops. What am I doing wrong? Oh, oops. There we go. So navigate to wherever you'd like in your file system, and you can also use the Finder window or what the File Explorer or whatever it's called in Windows too. But basically, you want to make a new directory, and so I am just going to call it code right here. And so we're gonna navigate into this code folder that we just created. And so as prerequisites for the workshop, I had you all download Node.js. So the next thing that we're gonna do is we're gonna type in npm init and -- yes. And let me paste that in here. So in your new folder, you're going to navigate into there and type in npm init -- yes. And so this is going to just set up some simple boilerplate for our project, which is just a package.json file. And so the next thing that we want to do is, now that we have this package.json, is type in some dependencies to install. And so the dependencies that we want to install are Apollo Server, GraphQL, and Mongoose. So I just I just, pasted the command in the workshop text channel. So go ahead and copy that into your command line and hit enter. And so this will install those dependencies. And so we're all set then. So after a short bit, you should have that. And so then the next thing that we want to do is just open this up. So go ahead and open this up in whatever text editor you'll be for this portion. So I'm going to be using VS Code. So I just have to type in code space dot. And all right, so there it is. Here's mine. And actually, give me 1 minute right here. I just need to pull something up, and then we can get back to it. Yeah. There we go. All right. So, um, so you should have your text editor open up right here. And so all that we should have in the project, or I guess the workspace or project, is a big node modules folder, a package lock, which is also big, and then the package.json. So for anybody new, so we'll talk about the package.json just a tiny bit for anybody that's new to Node.js. But basically what the main purpose of the package.json is to define any dependencies for your project. And so we just did npm install Apollo server GraphQL Mongoose. So all the dependencies for the projects, or sorry, the dependencies that you're using get saved in this little dependencies object, and then the actual code itself gets put into the node modules. And the package lock is also important, but I am actually not super sure what piece the package lock plays in the puzzle. But if I were to give this package.json to any other developer, they could also install all of these dependencies just by typing npm install. They don't have to type in npm install Apollo server GraphQL Mongoose. And so the next thing that we want to do is we want to create a index file, which is going to be our entry point into the project. Well, it'll be Node.js's entry point into. So you can do this one of two ways. You can say touch index.js if you're using the CLI. Another way to do it is to, if you're using VS Code, to hover over here, click new file, and oops, that went into node modules. Click that and type in index.js right there. All right, and so the the next thing I want to do real quick for any of my VS Code companions out there is to show you an extension that I would highly recommend you in your project. So so click on if you're using VS Code, click on your extensions little button right here, and then in the search bar right here, just type in GraphQL, and towards the top, you should have this extension right here. It's just titled GraphQL, and the author is the GraphQL Foundation. So make sure it's the GraphQL Foundation. That's how you'll know it's the right one. You can see like right here, there's another one, another GraphQL extension, but we want the one by the GraphQL Foundation. And so what you're gonna want to do is you're gonna want to install it. And basically what this will do is it'll help incorporate the GraphQL ecosystem into VS Code for you. And the biggest benefit that we're going to be taking or utilizing is just syntax highlighting. And yeah. So go ahead and install that. I don't think you need to restart VS Code, but if it's not working, then you might need to. So just keep that in mind. So yeah, so with that all done, we can get into the project. So so the first thing that we can do is we're gonna set up the server itself. So we're basically gonna set up the server, the GraphQL schema, and get it running. And then after that, we're gonna go into the MongoDB integration. So the first thing that we want to do is we want to import the modules that we'll be using. And so we're going to be using Apollo server, and this so we're going to import Apollo server and GQL from the Apollo server module. And I'm just going to zoom in a little bit just to make sure that you all can see what I'm doing. So we're just going to import that. And the next thing that we're going to do is we're going to start creating type definitions for our GraphQL schema. And so the type definitions that I'm going to be making the same as the schema examples that I had in the presentation. And so what we want to do to create the GraphQL schema is we're going to type in const type defs. And so const in JavaScript means constant, which means you can't change it. And then we're going to type GQL. And then the next thing that we're going to do is we're going to open up a template string. So a template string in JavaScript is a string that makes it a little bit easier to, well, it's a string that supports it, multiple lines, and it also makes it a little bit easier and a little bit more convenient to add variables into the string. So what we want to do is we want to do a backtick. So this is going to be at the top left of your keyboard. So an opening and closing backtick, and with a semicolon right there, and then we can start typing. And so this is kind of like a little fancy feature in JavaScript. So this is called a tag template, and basically GQL is a function, and but it's a special type of function, and I can like I can execute it and also pass in parameters with a template string, and then it parses. Typically, it'll parse the string and then give me some sort of result, which is going to be type defs here. All right, cool. So the first thing that we can do is we can define all of our custom types. So I'm going to start with user, and so like I was saying before, we just want to we define a custom type, but just by typing type and then the name and then opening and closing curly braces. And so at this point, you should start to see some syntax highlighting, and that's coming from the GraphQL extension that we downloaded. So if you don't see that syntax highlighting, then so make sure that you have the extension installed, and if you do, then I would restart VS Code, and hopefully then it'll work. So the types that I gave an example for the user for reference were an ID, a first name, a last name, an email, a password, and posts. Practically all of those were strings. So we'll go ahead and start implementing that. So the ID is going to be an ID non-nullable. First name will be a non-nullable string. Last name, also a non-nullable string. Email, non-nullable string. Password, again, a non-nullable string. And then lastly, we get the posts here. And this will be a non-nullable list of non-nullable posts. And let me put this in the chat real quick. Oh, Alex, I see. Yeah, so that is just from the theme that I'm using. So I'm using a theme. I don't remember what theme I'm using, and I honestly can't remember how to check. But yeah, it's just a theme that I'm using, so don't worry about the italicization. Yeah, don't worry about that. So I just pasted that first type in for you guys. It's formatted a little wonky, so you'll just have to fix that. And so the next thing that we'll do is we'll define the user input, which is what we were using for the create user mutation. And so for this input, we had a string that could be null, a last name, whoops, that could be null, an email that should never be null, and lastly, a password that should never be null. All right. So I'm gonna go finish up the rest of the schema, and then I'll just copy and paste the full thing once I have it done. And so then we'll have a type post. So this is going to be very similar to the user. So it'll have the ID, which will be a unique identifier, non-null, and the user ID, which will be a string. And just as a reminder, the reason why we're doing a string here instead of ID is because the ID is supposed to be a unique identifier. So if we have both, it'll be mad at us. And the IDs are serialized the same way as strings. So so if we want to point to something else, we would just use a string. And so content will be a string, non-null. Likes will be an integer, non-null. Dislikes, oops, will be an integer, non-null. And then comments, which will be a non-nullable list of non-nullable comments. And then the next thing I want to do is add some timestamps here. So we're gonna add created at and updated at. So in the whatchamacallit, in the presentation, I had these as strings, but I'm gonna do integers right now, and I'm gonna assume that I decided to just assume that they'll be stored as Unix timestamps. And so I'll also show how to make comments. So you can also, ooh, my Discord just, uh-oh. Hello. Can anybody hear me?
Yeah, you're good.
No.
Oh, okay. My Discord it refreshed. I got a little weird. So we'll just make a comment here. So if you want to make a comment in a GraphQL schema, you just use use a pound or hashtag. And then we just have one final custom type, which is a comment. And for the comment here, we'll have another unique identifier, a post ID string that'll point to a post, content of the comment will be a string, likes, integer, dislikes, also an integer, and then a little created at and updated timestamp. And so I'll copy and paste that all in. There you go. All right. So that's everything for the custom types. And I guess I probably shouldn't have sent that. So let me just delete that because we still do the queries and mutations. And so the final things that we want to do are the queries and mutations. So at the top right here, make query, and we'll do get all posts, which will return non-nullable list of non-nullable posts. then get posts by user ID. And so like I was talking about earlier, so this is going to take in a user ID parameter. And so we create those parameter, or we show that it's going to take in a parameter by using open and closing parentheses, very similar to Java. Oops. And so this will return another non-nullable list of non-nullable posts. And then we'll have a whatever function, which will be expecting something called an email. That'll be a string, and we'll return a user, which could be null. All right, and then last but not least, we have our mutation that we want to define. So this is going to be create user, and this is going to take in an input, a user input that is, and it will return a user. All right, so let me copy that all for you guys. All right, there you go. So if you didn't feel like typing that all in, just feel free to copy and paste. All right. So we have the type definition down. So this is more or less our schema in GraphQL. So now everything that we do is pretty much going to have to live up to the expectations of the schema. So the next thing I want to do is we're just going to create some like dummy data that we can use. And so I'm just going to copy and paste this in. And so I'll give it to all of you first. All right, so go ahead and copy all of that. So we have a list of comments, posts, well, yeah, a list of posts, and then a list of users. So go ahead and copy all that in. And so we're gonna just go right under your type defs and go ahead and paste that in. So all of your data should be it should be another variable like right under your schema. It shouldn't be anywhere inside of the schema. So if you indeed much wow, if you put this dummy data inside of like this GQL, inside of this template string in the GQL call, you'll get an error. So make sure that it's outside. It's completely outside of all that. And so now that we have this custom data, the next thing that we need to do is implement these resolvers that I was talking about earlier. So basically right now we're going to connect the schema to the actual data itself. So now we get to actually define how the API should get this data. So to do that, we're just going to scroll to the end of our file, and so we're going to make a plain old JavaScript object, and so we make a JavaScript object just by using an opening and closing parentheses, and then we're going to define a field inside of this object called query, and that's going to point to another object, and then inside this object we're going to implement all of the functions for all the queries. So the first one that we'll do is get all posts. And so for anybody that doesn't have a ton of a ton of experience with JavaScript, this might look like if you're coming from like Java or C, let's say, this might look a little weird. So basically like this resolvers, sorry, so this opening closing here, maybe I'll if I do it this way, it might be a little bit easier to show. So like this right here is an object, this outer opening and closing parenthesis, and then inside of this object we can have key value pairs. So query right here is like a key, and then the value is another object. And then inside of that object, we're going to have a key called get all posts. And the value of this is going to be a function. And so that might that might feel like a little weird for anybody coming from Java or C, but JavaScript is cool and lets us have, or has a concept of anonymous functions. So this function doesn't have a name, but I can access it by using um, uh, this get all posts key. So it's almost like making a variable for a function. So that's kind of the idea. So anyway, so in right here, so get all posts is just going to return all the posts. So all we have to do is just say return posts. And so that is just like that's just how you do it, and that's all we have to do. And if you want to get spicy with JavaScript, you can do it another way. So in JavaScript, there are arrow functions, and so arrow functions basically um, make it so that there's less you have to write when you make a function. And so I can make an arrow function by basically there are kind of like three parts to an arrow function. There are defining what the parameters are for the function, and then whoops, the arrow itself, and then the function body. And so in here I would do the same thing. So I would just say return posts. But you can actually get even more succinct with JavaScript. So I could just say get all posts, and I could say posts. Oops. So I could say get all posts and opening and closing parentheses, arrow, and then my return value. And so when you're using arrow functions in JavaScript, if you don't have an opening and closing curly braces, well, you can omit the opening and closing curly braces to just say what the return value is going to be. So if I omit them, then JavaScript knows that the return value is just going to be the posts. And so yeah. So we can delete all these other ones. So at the end of the day, just make sure you have get all posts, arrow function, return posts. And so the next thing that we are going to implement is the get posts by user ID. So we're going to do something similar to what we did up top, except we're going to name this key get post by user ID. And so we'll make this a function. And so the function is going to take in a parameter called user ID. And so now we get to implement it. So basically for this function, what we want to do is we want to loop over all of our posts and return all the posts that have a certain user ID. So what we want to do is we want to have a return value, which is just going to be a list. So this is going to hold all the posts that we want to return. And the next thing that we want to do is we want to create a for loop to iterate over our posts. So what we want to do is say for let I equals 0, I is less than posts dot length I plus plus, and then opening and closing curly braces. And so this is very similar to Java. The big difference though is that you wouldn't say int I equals 0. You would say, oops, let I equal 0. And that's because JavaScript is not statically typed like Java, and you don't have to define something to be an int. But other than that, yeah, this looks very similar to Java, and hence the name JavaScript. So the next thing we want to do is we want to so as we're looping over, we want to get the current post that we're on. And then we want to check to see if we want to add it to our return. So we'll have an if statement here. So we want to check the user ID, and we want to compare it to the user ID that was passed into the function right here. So the way you compare strings in JavaScript is by using triple equals sign. And so if this returns true, then we want to push this post to our return value. And so arrays in JavaScript they're very easy to create. So you just have to create a variable and then an opening and closing curly brackets. And so arrays in JavaScript have a function called push, which puts a new item at the end of the line. And so that's how we'll be using that's how we'll be adding new posts to that. So it's in Java, this is similar to add from array list. And then so at the end of our function here, we just want to return all the posts that we found. So return RV. All right, and so we've got oh, sorry, I actually made a small mistake. So what the function is actually going to be accepting are 4 different parameters. And the reason it's going to be accepting 4 different parameters is because we're using Apollo server to set up the server for us. So whenever this query gets called by the client, Apollo server, which is the library we're using, is going to pass different objects into the function. And so these objects are going to be called parent, args, context, and info. And to quickly describe these a little bit, so parent is going to represent the previous resolver that was called. So what's interesting is that you can call resolvers one after another. We won't be doing that in this workshop, but you can use parent to get to access aspects of the previous resolver in the resolver chain. So args here is going to contain any of the variables that the user passes. This is actually how we're going to access the user ID that gets passed. Context here is a variable or an object that holds any information that could be relevant to the to the program or the script. So for example, I could put a database instance in here. We're not going to be using it though, but that's one way you could use it. And then info right here is going to hold any other info relevant to the query. So we actually need to make that modification, and there's one other modification we need to do now. And so what we want to do is we want to say const user ID equals args.user ID. And then we're all good. All right. And so we have one final query to implement, which is called whatever. And so one thing we could do is we could write in all 4 of those parameters that I just covered. But since we're only using args, it might actually be better to not type all of them. Like there's no point in having them in the function if we're not going to be using. So what we can do is we can replace parent with just an underscore, and then we can put in args right here, and oops, sorry. And so this is kind of when you replace a parameter name with an underscore in JavaScript, that's kind of shorthand for you're not going to be using it. And then since we're not using context and info, we don't have to mention them. But since we need args, we need to basically we need to put that other parameter in front of it. So if we only put args in here, this would actually be the parent. So that's why you kind of need that buffer to get args. And so for implementing the rest of the function here, so basically we need to find, so whatever is supposed to get a user by their email, so we basically need to find a user by their email. So what we're gonna do here is we're gonna utilize a function or an array function called find that you can use in JavaScript. So we're gonna say return users.find, and so find is an interesting function, and so this is things like these are very common in JavaScript. So find is a function that actually takes in a function as a parameter. So this kind of looks like this. So and so you put in a function like that, and you open the body. And so the find function, basically the idea is that it's going to loop over every item in this user's array, and it's going to perform this function on those on the items until it gets a match. So now we need to implement the logic that we want. And so what find also does is it passes the current element into this function that we pass as a parameter. So we could call this whatever we want. We could call it Steve, but to make more sense, we're going to call it user. So for each user and users, what we want to do is basically we want to return a Boolean, and find is kind of defined as if this function returns false, then it's not a match, and if it returns true, then it is a match. So what we want to say is we want to return user.email equals args.email. So that's the idea here. So it might look kind of weird to have two return statements like this in one function, but basically, so like this return statement is going to be for this anonymous function that we're passing into find here, and it's returning whether or not this user was a match based on our logic. And if it was a match, then we're going to return that. So that's kind of the idea there. Hope that clears that up a little bit. All right, so now we have all the queries set, and so the next thing we want to do is define resolvers for all the mutations. And so we just have one mutation, so this shouldn't be too bad. But we're basically going to do the same thing as up in the queries. So we're going to make another key for this object called create user, and that's going to be a function that takes in args. And so basically what we want to do here is we want to get all of the fields that the user passed in for the new user, and then make a new object that holds all those fields, and then push it to our list of users. So so we can do that this way. So so we're gonna get input from args. Whoops. And so I know that there's a field called input on args because that's how we define create. So input, so this is straight up where input is coming from. And so now what I want to do is I want to create that new user. So in JavaScript, like I talked about before, I can just make a new object by opening and closing curly braces just like this. And so we want to put fields inside of this object for all the fields that we got from the user. And we also need to create a new ID. So what we're going to do for the ID is just something simple. So we're going to get the number of users and add 1. And so for first name here, we can just put in input dot first name. Whoops. Make sure you don't do a semicolon. Make sure you do a comma. For last name, we are going to say input dot last name. And for email, we're going to say input dot email. And then for password, input dot password. And so we also have to make the posts, the post field here. And so we don't get posts from the input. So this is just going to be an empty array. And so that's our new object. And then what we want to do is, like I said before, is we push this to our current list of users. And since we said that the create user mutation was going to return a user, we're going to return the newly created user. So there we go. And now we're all done. So we just implemented all of our resolvers. So we're all set. And so I'll copy and paste this into the chat just in case somebody wants. Resolver. I barely know her, indeed. Actually, Matthew Chung knows resolvers very well. Right. There you go. So just feel free to copy and paste that in. So we'll save this real quick. All right, so at this point we have the two biggest parts of the GraphQL server or API. So we have the type definitions and we have our resolvers, and then we also have the dummy data. So we have 3 most important parts. And so the next thing we want to do is we want to finish up setting up the server. And so this is going to be the easiest part. So what we want to do is we just want to scroll down to the bottom of our file, make a couple new lines, and so we're going to make a new server. And so this is very easy to do. So we just say const server equals new Apollo server, and we're going to pass in an object that contains our type definitions and our resolvers to this function. And so what we want to do here is we can just say type defs and resolvers. And yeah, so that's that. So, and then Apollo server handles everything else from there. So it connects the type definitions to the result and does all that jazz. So we don't need to worry about connecting anything else at this point. But the thing that we do need to worry about is actually starting the server. So the way we start the server is by typing server.listen, and so what this listen function does is it returns a promise. And so if you're not familiar with promises in JavaScript, basically when I in a kind of in a nutshell, when I use a function that returns a promise in JavaScript, it's kind of running asynchronously. But what promises do is they guarantee some sort of return value or error from that function. So what I can do is I can say .then, and then I can basically pass in another anonymous function to do something when this promise or when that function finishes. So I'm gonna create another new function. And so we are gonna do this here, and then open and close our curly braces. And so what we're doing here is something kind of fancy in JavaScript. And so this is called destructuring. And so basically what gets passed into this function is going to be some sort of object, and this object has a field called URL. And so destructuring is basically saying I want specifically the URL field object and nothing else. It's kind of similar to GraphQL. And then when I do that, I can use the URL however I want. So I could say I could console log it, for example, which is almost exactly what we're gonna do. So what we're gonna do is we're basically just gonna log that the server is ready and then give the URL. And so what I want to do is I want to open up a template string, so hit those backticks, and then what I want to do is I want to get an emoji. And so we're gonna type in the space rockets. And we're gonna add the space rocket in, and we're gonna say server ready at the URL. And so I was mentioning earlier how template strings make it a little bit easier to use variables in strings. So if I did it the old-fashioned way, I'd have to say something like server ready at, and then put in a plus and then URL, which is a little annoying because then if I wanted to, like, I have to break up a string if I want to type in anything else. So template strings are nice because they let you add in variables like inline. And we are going to the moon, so obviously space rocket. And so yeah, so that is so at this point it should be all set. I don't think I really explained then. So .then is basically saying I want to perform this function when this one finishes. And if you want to see this an alternative way in JavaScript, so some people actually don't like doing like .then because it creates like callback hell. So alternatively, what you can do is you could say const URL equals await. Oh, I might not be able to use await actually. Oh, I don't think it'll let me use await. For an example, what you could also say is server.listen, and basically what await says is, so like I said earlier, this listen function is basically going to be asynchronous, but await basically makes your program act as if it was the program was synchronous. And then what I could say is console.log server ready at URL. So that's just an alternative way to do it, and in my opinion, it looks cleaner this second way. But yeah, so we're all set here. So then the next thing you can do is you can bring your command line back over, and you can type in node index.js. There you go. So I'll copy and paste that back in here for you all. There we go. And so yeah, go ahead and type that in. That's how you can start up your server. Yeah. So I guess at this point, is there anybody who is following or that tried to run their server and is having any errors? You're okay. What's going on with you, Alex? We have. Okay. Very cool. Let me know if there's anything else. Anyone else have any errors or anything? If not, then all right, sounds good, Alex. So if If not, then I'll show you. If not, then we can just go to localhost 4000 and see what is showing up here. So open up either Firefox, Chrome. Don't use Safari because Safari wasn't working. So type in localhost 4000 here. Just on a web browser, preferably Firefox or Chrome. And so after you type in that, you should come to this page. And once you get to this page, click on Query Your Server. And if you're here, then basically what this is like an IDE for you, or a sandbox for you to play around with your API. So I originally asked all of you to download Postman or GraphQL Playground, and that was because I forgot that Apollo server sets up this IDE for you. So you can actually just use this. But another really cool thing about Apollo server is that it it bundles this like little IDE with itself. So when it runs, you can go to wherever your API is being hosted, whatever URL, and you can play around with it and test things out. And so like on this left side, you have basically like documentation for all of your queries and mutations. Down here on this tab, you can define variables for different things. And then right here in this code editor is where you actually type in or make your queries. So to kind of demonstrate this, let's try out some of our queries. So let's do get all posts. So what you can do is you can either click on query on the left side right here and then click this plus by get all posts, and it'll auto generate the query for you, and then you can just type in what variables you want to get back. So you can type in ID, user ID, content. You can also use the pluses on the left side right here to automatically put in the fields. Oops. So yeah, you can also just type this. So let's go ahead and then click get all posts. All right. So we defined that we're doing a query. We define what operation we want to perform, and then we defined all the data that we want to get back, and we got it all back right here. All right. So as you can see, I have all the comments for this post. But let's say I didn't want the comments. Then I can just delete this and click the run button again, and now I have everything except the comments. So like I was trying to say in the presentation, the power of GraphQL is that it really lets us customize what we get back from the server. So the next thing that we can do is we can try out mutation. So let's clear up this here. So let's go back to this mutation here. So we'll add it. We're gonna add the create user mutation. And so in this little bottom tab right here, is where we define our variables. So we have a parameter called input. So it's already got that set up for us. And so input is going to be an object. And so like we defined, there's going to be a first name. And so you can put in whatever you want. You can put in my name, Tony. What's also cool is that if we all right, anyway, I'm not super sure why I'm getting that error yet, but I think we can just keep going. So last name is Comanzo, and so we also had to put in a email. So say T. This is my Albany email. And then I say a password. Should just use random characters. All right. And then up here we can define what data we want to get back. So I'll just say the first name and ID. All right. So now, if we run our query, oops, we get an error. Cannot return null or non-nullable field. All right, let's debug that. Interesting. Oh, that's why. All right, so the reason it's giving us an error is because I said ID, not underscore ID. So make sure you have underscore ID right here, and I'll update the. Do I need to update? Yes, I do need to update. So I'll update what I pasted. Whoops. Alrighty. All right, so make sure you have the underscore ID in your create user resolver. And so since we just edited that, what we have to do is we have to turn off the server and then rerun it. And you have to rerun it so that it'll have the most up-to-date feature changes. So once you've done that, we can try running this mutation again. And there you go. So we've got a new user with an ID of 2 and whose first name is Tony. So this is all cool. Oh, I see it typing. Yeah, I guess I should. I'll take a little stop here. So does anybody have any questions? Oh, okay. Yeah, see you later, Matt. Thanks for calling. So yeah, so at this point, does anybody have any questions? Error. All right. Yeah. So if not, we can just keep going then. So what we have here is all nice and dandy, but the only issue is that we've created this user, but it actually won't persist with the in our little program. And that's because every time that we run this, we've defined here that user this list that holds an object that holds this user. So basically what happens is this new user that I just made gets stored in memory until the program ends or until I shut it off. So for example, note how the ID is 2 right here. So if I turn off my server and turn it back on, so say we make another user, their name will be Joe, last name Schmo, and jschmo@albany.edu. So say I update the variable like that a little bit, and then I run the mutation. So we're going to get Joe back for the first name, and then as you might notice, we still get 2 for the ID. And that's because the Tony commands that I just made didn't persist. So the only way that we can one way that we can persist the data is by connecting our server to a database. And so that's what we'll do next. So so what we want to do is we want to go back to our MongoDB. And so this should all be good to run now. And so what we want to do next is we want to click on connect here. And after you click on connect, we want to click on connect your application. And what we want to do is we want to copy this connection string. And so this connection string is what we're going to be using to connect to the database. So you can click this button right here. I guess of things to note, so it says right here you replace password with the password for whatever the name of your user was. My first database we're gonna leave in there, so don't touch that. But basically, right here where it says password, is where you're gonna put your password, or replace with your password. So go ahead and copy that string using the little button right here, and then we're gonna come back into our VS Code, and so at the top right here, so right now we're gonna create our connection to MongoDB, and so what we need is we need to import another module. So we're gonna import mongoose. So we just type in const mongoose equals require mongoose. So we import that module just like this, and so we're gonna scroll all the way back down to the end of the file, and we're gonna make a little variable called db to hold the database string that we just copied. And the important thing, like I was talking about, is to replace the password with your actual password. So my password was password 123456789. So just put whatever password you had right there. And then the next thing that we're going to do is we're going to write logic for connecting to the database, and then also setting up the server after we've connected to the database. So to connect to the database, we're going to type in mongoose.connect db. So it's going to give it the database string. And then what we're going to do is we're going to add in a JavaScript object. So an opening, closing curly brace. And we're going to open up that object, and we're going to set some fields in that object. So the first field that we're going to set is called use new parser. And we're going to set that to true. And then the second one we're going to set is called use unified topology. And we're going to also set that to true. And then, so it's going to connect to the database. And then, so this connect function also returns a promise. So what we're going to type here now is .then. So we're going to use this to perform a certain function after it's connected to the database. So we're going to type in function opening and close parentheses, and then opening and close curly braces. And so we're going to type in here console.log just connected to MongoDB. And then what we're going to do is say return server.listen. And so when we say return server.listen, so I said earlier that listen returns a promise, and when we return a promise inside of the then function, it passes it down into a chain. So I can say .then result, sorry, function result, and we'll say we'll just copy this console.log in here, and we're all good. And so we can delete this original connection logic. All right, so this is what your connection logic should look like now. And we can run this real quick just to make sure that it works. Oops. Server ready. Oh, that's why. So we actually want to say result.url. All right, awesome. So at this point, you can, we should be connecting to the database and the, and also creating the server. So I will post the connection logic in here. Just make sure that you use your own database string. All right. So, all right. So at this point, so we're connected to the database, and the server is also running, and so we can use our API just as before. But right now it's not set up to actually interact um, with the database at all. So the next thing we'll be doing is setting up a schema for the MongoDB database, and also uh, changing our create user resolver to actually touch the database. So the next thing that we want to do is we're going to create 3 different files. So we're going to create 3 different files, or 1 file for each model in our GraphQL schema. Well, I guess, sorry, 1 file for each model that will be in our database. So that'll be user, post, and comment. So right in here, we're going to say, we're going to create a new file called user.js. And so when we, inside of user.js, what we're going to want to do is first import some things from Mongoose. So we're going to import model and schema from Mongoose. And then what we're going to do is define the schema. And so we'll go through the first schema together, and then I'll copy and paste the other 2 schemas. So we create a schema by creating a variable. So we're going to call this a user schema, and we're going to say new schema, open parentheses, and then we're going to pass in an object. And then in this object, we're going to define all of the different fields for the model in the database. So basically, we just want to mimic what we had for our GraphQL schema. So we're going to have first name, and we're going to make a new object here. So the type for that will be a string. And the way we can copy whether something should be nullable or not with a MongoDB schema is by using this field called, this field called required. So we'll set required to false, and so that's saying that it could be null in our database. And so we're going to do the same for the last name. And then for email, we'll make that a string as well, except right here, we're going to make it true because it is required. And whoops. So next we'll have password here. So this will be another string, also required. And so then lastly, we have to figure out how to do post. So so we know post is going to be a list of other objects. So far for all of the other fields we've had, we've used these opening and closing curly braces to say that it's going to be just like it's going to be one field, and it's going to hold a value of type string, and that is required. So in a Mongoose schema, the way that we show that something is a list is by using opening and closing brackets. And then what we can do is define what an object inside of that list should look like. So I'll have an opening and closing curly braces here, and we're going to define the type here. And so we're going to say schema dot types dot object ID. So this type it's something built into MongoDB. So basically, whenever you create a new element for your in your MongoDB database, it'll automatically generate an ID, and it's of type object ID. So um, That's what that is. But it's going to be a reference to a post. And it is also going to be required. So these objects are also going to be required. All right, and so we're all done setting up the user schema. Actually, we're almost done. So the last thing we have to do is some final setting up. So at the bottom of our file, we're going to type in const user equals model user schema. And then lastly, we have to export this module. So we're going to say module.exports equals user. And so what this little line does is it basically it wraps our schema in a big object and it exposes various functions to us. For example, whenever we make a new user, there's a function called save that we can use to save it to the database. So there are just some useful things here. So I will copy and paste this into the chat as well. So there's user, and then likewise we're gonna make a post file and then also a comments file. So we're gonna make post.js and then comment.js. And so what I'm gonna do here though is I'm just gonna copy and paste the code for all of these in. Since it's getting late, you all already know about that schema from the GraphQL. So there's post in the chat, and let me get comment. All right, there you go. So just make two new files called post.js and comment.js, and then copy and paste those schemas into those files. And you should be all good. All right. So we've got the schemas set up, and so now we're gonna rewrite some resolvers. So we're only gonna rewrite one resolver. We're just gonna rewrite the create user resolver. So we're gonna create a user and put it into our database. What we could do is we could also write mutations for creating posts and comments, but since it's getting late, we'll just do create user. So all right. So basically what we can do is we can copy what we have so far and paste it down here. Just you can comment out what you have already if you want. And so we're just going to make some slight modifications. So what we want to do is so at the top of the file here, we're gonna import this user this little user like model or class that this made. So at the top of your index.js, type in const user equals require user. And so that'll import the class. And so what we want to do here is so we're going to rename this variable that we have here just to model, since we're importing something called user. So just rename that variable to model. And then what we also want to do is we want to delete this ID, because MongoDB will automatically generate the ID for us. So we don't need to be concerned with that anymore. So go ahead and delete that. And we're also going to delete this line right here that says users.push user. We don't want to push array anymore, since we're going to be sending it to the database now. So right here, what we're going to want to type is we're going to make a new user using this user class that we imported, and we're going to pass in the model. And so, like I was saying, once we create this new object, we'll have a lot of new functions exposed to us that make it really easy to interact with the database. So we're going to type next const result equals await new user dot save. And so what new user dot save does is it saves this new object into the database. And so save also returns a promise. So you can either use a dot then after this or use await. And I like to use await because I think it looks cool. And then the other thing, the final thing that we want to do is we want to make this an asynchronous function. We want to make this whole function something called an asynchronous function in JavaScript. And you can only use the await keyword in asynchronous functions. So that's why we have to do that. So, and to do that, we just type up async right in front of the function declaration. So this should be the final, oh, sorry, not the final. The last thing we have to do is return the result. There we go. This is the final. So I'll go ahead and copy that in here for you all. All right. Any difference between async and defer? I am not familiar with the defer keyword. I didn't know that was a thing. Yeah, if I knew more, the defer keyword is entirely new to me, actually. I don't think I've ever heard of that before, but yeah. All right, so yeah, so this function this resolver that is should all be set up to your database. So we're gonna go test that out. So go back to your command line and kill what's running and restart the script. Oops, error. Cannot find module. Oh, that's why. Okay. Make sure when you're importing that you / instead of just this. This is how you should be importing. There you go. And okay, let's try that again. All right, yeah, there you go. That gave me a lot of scaries 10 minutes before the workshop. All right, so let's go back to our little IDE. And all right, so let's try out this mutation and then see if it actually did anything in our database. So let's clear up this and go back here. Let's add a mutation, add in create user, and we'll get back everything. And we'll just save for this to return the ID. All right, here's the moment of truth, people. So, yeah, so in our little code editor here, we'll say that we're doing a new mutation that we're gonna call or do the create user mutation, and then just define all the stuff we get back. So let's see if it does. Hey, there we go. All right, and let's see if it changed anything in the database. Oh, all right. So this is a good sign. So what's cool about MongoDB is that it also shows you these network analytics. But to actually browse the data, you click on Browse Collections. And then on the right side, sorry, on the left side, we have users. And right here, we have Joe Schmo. So yeah, there you go. So, and then, so if you go back to our little variable right here, so this is exactly what we inputted. This is what we're getting back. And it is, whoops, in the database. So that's cool. And yeah, so that is GraphQL and MongoDB. So yeah, if there was more time, we could have implemented the other. Since it's already 10, I think this is a good spot to stop. So then I just had a little bit of the slide deck left to talk about. So where do we go from here? Um, so the current setup does have a few problems, namely that you have to define a schema both GraphQL and also MongoDB. And having to maintain those two different schemas is really annoying. And so the idea is like, what if you could just have one and just be done with it? And so some improvements that you could implement are adding in like code generators like GraphQL Cogen or GraphQL Compose Mongoose. Um, so what GraphQL Cogen does is it takes a GraphQL schema and it generates types for you. And then alternatively, we have GraphQL Compose Mongoose, which takes a Mongoose schema and generates a GraphQL schema. Um, so these code generators uh, um, take away some of the heavy lifting. So it's a little nicer to just have one schema to worry about instead of two different schemas that you have to update. There are also object relational mappers that you can, and I'm not super familiar with them, so I'm not going to talk about them too much. But two big ones are type ORM and then Prisma. And then another improvement that you could add is also using TypeScript instead of JavaScript. And so adding in TypeScript or if you use TypeScript, you can use a cool combination. You can use two different libraries. One's called TypeGraphQL, the other is called TypeGoose. So TypeGoose is the TypeScript version of Mongoose, and TypeGraphQL basically will generate GraphQL schema from um, TypeScript classes. And what TypeGoose will do is it'll generate a Mongoose schema from a TypeScript class. So basically what you can do is you can just create one TypeScript class and then generate a GraphQL schema and a Mongoose schema from it. And I did that for a project that I didn't finish. But I'll show you what it kind of looks like. Uh, so, um, so I have a, so this is in TypeScript. So I have so I'm using TypeGoose and I'm using TypeGraphQL. And so I have just a TypeScript class. And so the idea is that you annotate um, that come from those libraries to define or to help create those different fields. Um, so yeah, this is like kind of what it looks like. Um, so for example, I like prop. I can't remember. I think maybe this at field is coming from TypeGoose, and then I think maybe at prop is coming from TypeGraphQL. I'm not super sure, but it's I'm using these annotations to, I guess, wrap this field in this class, and then these annotations help um uh the libraries generate schemas. So yeah, that's kind of what that looks like. And then for your further enrichment, I have some links that you can take a look at. So I have this link right here if you'd like to learn more about APIs, and then I have a plethora of related links and tutorials. Um, uh, these three are a couple of tutorials. So this is somebody's making it's a playlist of somebody making a Airbnb club with GraphQL, and then this one is like just another playlist, but making like a app with TypeScript and GraphQL. And then we have a full stack tutorial right here. So this is like 13 hours. It's definitely worth it. And it also involves GraphQL. So if you have that time, I would definitely recommend it. Right here is the specification of GraphQL. So like how everything is like this is like the formal like specification of how everything works. You can read about all the types here and things. Then this was like a little article about the current state of GraphQL in 2021 that might be interesting to read. And then there's also a link to a GraphQL FAQ if you have more questions about GraphQL. And then Neo4j is a really cool technology that utilizes it was pretty much built to use built to be used with GraphQL. It's a NoSQL graph database, and there are the node library for Neo4j will automatically generate all of the resolvers for you. So that means you don't need to use, or sorry, you don't need to define any of these functions, like any of these basic functions for getting posts and things like that, like getting all the posts. Like it literally just does that all for you. And but if you wanted to create custom resolvers, you can also do that. But yeah, Neo4j is really powerful. It also I can't remember exactly what milestone it hit, but it like hit like some sort of thing like most funded or like most backed like database company or like some I don't know. I can't remember. It was something similar to that. Um but that was like a really big milestone for it. And then there's also this fancy schmancy stack called the Grand Stack that utilizes GraphQL and also Apollo Server and Apollo. So we only talked about Apollo Server today, but the client that you can learn about if you're interested. And it also utilizes Neo4j, and it's meant to be used with React. And I had experience working with this stack over the summer, and it was pretty cool. Um, so yeah, and yeah, so that's it. So thanks for coming, and thanks for sitting through all that. So does